Welcome back, everybody. So we saw before that the reals are dominated by the power set of the natural numbers, and which is the same as the functions from the natural numbers to 2, and that the power set of the natural numbers are dominated by the reals. And then we say, well, that doesn't imply that they are equinumerous. Well, equinumerous means there is a bijection. And what we prove here is that there is a one-to-one map from here to here, and there is a one-to-one map from here to here, right? So we have two one-to-one maps, but does that imply that there is a bijection between them? What we're going to prove right now is that yes, if you have that there is a one-to-one, that A is dominated by B, it's a one-to-one map from A to B, and that B is dominated by A, it's a one-to-one map from B to A, then there is a bijection between them. So you have to build this bijection, okay? So I'm gonna give you the picture proof. I don't want you guys read the details in the textbook. So here is the proof. So let's suppose we have a set A, and here is our set B, okay? And we know that we have functions, and by our assumption we have a function that goes from A to B, and is of course one-to-one. And we have another function G that goes from B to A, and it's also one-to-one. And we want to define A from A to B bijective. So the problem that we have is that F and G might not be onto, right? So they might both be missing some part of the other set, and then what do we do? So let's draw G up here. So G, let's suppose we arrange the elements in our picture so that G kind of looks like this. So this is G, and let's suppose it maps everybody to inside this set, and it's going to leave this set out. Yeah, so the function maps all of B into all this part of A, but leaves this part out. So that's why we're missing to get a bijection. Okay, so here's the construction that we're going to do. Let this0 be the image under F of this set C0, and this is through F. Okay, so that goes somewhere there in B. And now we're gonna go back through G, and we're gonna get here some set C1. So let C1 be the image of D0. Okay, so that's how we get this one, and this one is disjoint from C0. Well, because C0 is disjoint from the range of G, and C1 is pretty much inside the range of G, right? So this one is disjoint from the range, this one is inside the range. So these two guys are disjoint. And then we're going to keep on doing the same thing. Now we're going to apply F to this guy, F, and we're going to get D1, and then we're going to apply G. By the way, D1 is disjoint from D0 because F is one-to-one, and they are coming from disjoint sets, and if you go through a one-to-one set, you get disjoint things. And then once these two are disjoint, the images are disjoint because G is also one-to-one, so they have to go to different sets. And we keep on doing like this, and essentially we are defining these sets C0, C1, C2, C3, and D0, D1, D2, D3 all the way by induction. So essentially we can fix this part up here and say the n is the image of Cn and Cn plus 1. So essentially we have that Dn is the image of Cn through F, and Cn plus 1 is the image of Dn through G, which happens to be disjoint from all the previous ones the same way as the Dn's are disjoint from all the previous ones. Okay, so how are we going to define our H now? Well, now the key point here is that if you look at the spots that we have left open, this one goes, they are in bijection with each other. Remember, G, the image of the range of G is everything but C0. So we can map these blue parts backwards using G inverse. And they will stay on the blue parts. And then the red parts using G. So we're gonna let F of an element, H of an element A in A to be depending on which case you are. So if A belongs to some of the CNs, the union of the CNs, so if it belongs to one of these guys, then we use f of A, okay? So that means if it's like right here, it will go through f there. If it's here, it goes through f there. If it's here, it goes through f there. If it's here, it goes through f over there. And if it's on one of the blue parts, if A is not in the union of the CNs, then what we do is we go backwards using G. Backwards using G. Which we can do because C0 is A minus the range of G. So everything outside C0 is going to be in the range. So we can apply the inverse. And G is 1 to 1, so we can apply the inverse. So what do we need to see to see that this is 1 to 1 and onto? So what we need to see is that, so observe, so F is a bijection from the union of all the CNs to the union of all the DNs, because that's the way we define essentially the DNs. And the other thing to observe is that G is a bijection from the union of all the DNs to the union of all the CNs for n greater than 1, right? Well, because when we go in the other direction, in the G direction, we are going, we are skipping C0, right? So this one is being skipped, but all the D's go to all the C's, right? Now, if we take the complements, this one is not in the range of G, so that means that we get a bijection from the whole set B minus the union of the DNs, so if remove, this is the blue part, to the whole set A minus the unions of all the CNs. And here we are including all the CNs because this one is not in the range of G. So G is not, it's going to map these parts, the blue ones, to the blue parts, because it's the complement of the D's are going to go to the complements of the C's, except for this one, which is not in the range, right? So that's how we get, we divided the sets A and B into two pieces, and we have bijections between each other, F between going one way and G going the other way on the other sets. So that's how we get our bijection that proves that A is equinumerous to B. See you guys later.